So, welcome friends, this is the third session of our mathematics workshop on geometrical interpretation of mathematical concepts, and morning I have explored that what is, how math can be defined or what is math, and then I told that math can be explained through line, any function can be explained through line, and we explored again this straight line. And next as per my schedule, it should be the non-linear functions or curved lines, but timing, as we have started late, we will be covering transformation first, and then after completing transformation we will explore non-linear program. That will be again will be more meaningful, because by that time we will be knowing transformation and we will transform those non-linear lines. So, we will proceed in that way. So, I will skip few of the slides and starts from here. This observation, there are hundreds of functions, but the geometrically they represent a line. Agree with this point? Yes. So, how this will help us? This information, how it is going to help us? We are going to explore that point. Now, if you think a line, what is the constituent part of a line? Anybody? Yes, point. So, first let us try to define a point.
You got a point there.
Yeah, you got a point. So, what is that, how you can define a point? So, next question. Anybody can define a point?
A point should have two coordinates. One is x coordinate and y coordinate.
Very good.
Why not Z?
No, point one point.
Point in 2 dimensions should have a x coordinate.
At least two coordinates.
Okay.
At least
So,
two coordinates.
when we talk about it has to be x coordinate, y coordinate, we are telling that it should have a reference,
Right.
cross reference. There is a great fallacy in that system. I will talk about that to get clarity, not to confuse you. So, first thing, there is an x and y. This is clear. So, one way you can think it is domain, range. Okay. These things, and you are telling many students gets confused, but you just clearly tell them, you do not think anything else, x is domain and y is, just try to remember. That will help, means 90% cases you can solve the problem. And these are the x is the reference line, y is the reference line. But when x and y, what is the reference? Reference is functional relationship, functional relationship of y with x, functional relationship of y with x. So, y is equal to fx, this is the thing. Now, suppose x is a real number, x is a real number. So, what is the y? Your function is y is equal to x square. So, if it is a x is equal to 2, it is a real number, what will be the
That's not a real number.
4. So, where we should put it? In number line, in number line.
Yeah.
So, this, suppose you do not know this, you have not learned, Descartes has not arrived in our world, and we do not have any coordinate system. How you will going to put it? You will be putting it 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, like that, is not it? Minus 4. So, your 2 square, this 2 square you told. So, what is the 2 square is 4. This will be the 4. So, this is your x and this is your y.
Both of them are on the same axis.
It should be, because it is a number line. But what is the problem? If you are dealing with 4 5 functions, no, putting every function here and this corresponding range, and then after few exercise you will be forgetting which is domain and which is range. It will be clumsy. So, what you can do? You just think you are the not means discarded is not come and you are doing some problem like that. What else you can do?
You
Okay,
separate the
for
two.
separating you can put another number line. So, corresponding to 2 here it will be 4. So, this number line is for range and this number line is for domain.
How do I link the two then?
Link is this, 2 is 4.
Acha, first.
And actually when it has evolved in that fashion. People are trying like that, because both are number line. You cannot have different orientation, different things. Means here you cannot start minus here, plus here, or minus there, or here is minus here or plus there. It should have same orientation and same alignment. So, this is the thing. But in this also, suppose root 2, root over 2. So, something will come minus something and plus something, both will go to 2 like that. So, one range there will be can be 2 domain. So, again this will be a problem, and putting these sort of things again become problem. So, discarded what he has done, instead of putting this line he has put this line vertical number line, but this is also a vertical number line, but we put it vertically, and it has made our life simple again, and we do not question it. But orientation wise you cannot put a same place 2 number lines at different 2 orientation, but as we are putting vertical orientation, as this is also a number line, this is also a number line. Any doubt in this?
Yeah, but I mean, we get certain advantages. Is there a disadvantage to?
No, there is no disadvantage, but it was not come suddenly. People has to struggle to get this. As we are readily getting this, we are not feeling the pain. Sometimes some fellows has to
taken.
face for developing this. Is not it? So, if we summarize, this is the coordinate system, and this point here, all points we say minus plus, minus minus, and this is minus plus. These are the coordinate system of the
X, Y. Plus
x is plus and
Plus
this is
minus.
minus. So, this is the thing, but and we will go for transformation shortly. But when we will go transformation, we cannot say suppose A is transformed to A dash here, but we cannot say that this point has transformed. Point never transform. That is one thing we should keep in mind. If you do not know these things, there is no issue, there will be no problem, answer will be same, but knowing this and not knowing this is having some subtle difference in higher mathematics. Point never moves, that is one thing, and points always should have reference point, these two. Third thing, right hand system is not appearing here, but right hand system will appear when we will deal with 3 dimensional object. It is 2 dimensional, it is okay. And domain and range, I told what is domain and range. And scale again, nano scale, micro scale, macro scale, whatever scale we do, the coordinate system remains same, in the sense that earlier civilization, those are struggling for dealing with this astronomical things. Now physicists are struggling for calculating these micro scale level things, but the coordinate system for both the cases are same. So, scale does not change our requirement. So, that is a good thing I am telling. And dimension, what are the dimension means and how many dimensions are there? You NIPT fashion technology. So, dimension you can say more clearly.
We use 3 dimension to define physical objects. And when we are talking about things like movement or something, then we have to take another reference of dimension, which is time. And people talk about multiple dimensions. Even when we draw, sometimes we say you can draw the same picture in more than 3 dimensions.
Is there any physical object of multiple dimension?
Would you consider color as one of the dimensions, or color would be a feature?
It could be called a dimension, because it directly, now it's considered an emotion. Emotion could be a dimension.
But I'll tell you that there exist dimension higher than 3, and physical objects are there.
Time is a fourth dimension.
Well defined physical object. Time is not physical object. So there are physical objects.
Like?
Actually, dimension, you see, this is the dimensions. Point is a 0 dimension, and rule is drag and create. So when point you drag, it will create a line, 1 dimension. When you drag a line, it will create a plane. It will be 2 dimension. When you drag a plane, it will be 3 dimension. And
when you drag an object,
and
3D object,
yes,
you get a,
then what you will get? It will be another object.
No, but it will still be in the 3 dimensions, no?
It is 3 dimension. You are creating objects. You are creating objects. So creation wise, you are moving from 3 dimension. When you are dragging a solid, you are not in 2 dimension then, no? Plane is not a 2 dimension, 3 dimension. Plane exists in 3 dimension, but plane is not a 3 dimensional. So similarly, 4 dimension, I drag a solid, it will be a 4 dimension. It is existing in 3 dimension space. It is a 4 dimension, and if you drag that 4 dimensional object, it will be a 5 dimensional object.
So basically, it's the action.
Drag and create. Drag and create.
So basically, you add a drag, so it will add a dimension.
so your 4 dimensional box hypothetically is still a 3
Not
dimensional box.
hypothetically.
Is still,
Forget about hypothetically. It exists.
It's just a larger box.
It larger box. Let us explore. See, this point, line, square, cube, hypercube, hypercube, all have definite relationship, the vertex, edge, face, solid, hypersolid, and dimensions. So all these are physical objects.
What would be a hypercube?
Hypercube having 32 vertex, for 80 edges, 80 faces, solid 40 solids, 10 hypersolids, and 5 dimension. And not do not ends there.
Me too. Do we have a picture of
Everything having picture? I have not included because I want to show many things, so it will divert the attention. So we will end here. You know that it is exist, and for the same sake, why when we talk about dimension, we should not restrict it to natural numbers or integers. It can be 0.5 dimension, 0.2 dimension. Agree? These are the things what is called fractals.
तो hyper कब तक लगता जाएगा?
You drag and create. That is
hyper.
Yes.
Yeah, that is
yes.
why people in math say the n-dimensional space.
Yes.
So that n-dimensional space is that hyperspace. And hyper how many? n minus 1 hypers. There.
The Stephen Hawking dude, he's sitting and trying to answer one question.
And now I am coming back to that point again, coming back to the point, and point here is also one thing I told you, that point never moves. So, what moves? What moves? That vector representing or position vector representing that point moves. So, vector we read or do not read, indirectly we learn about vectors. So, when we multiply something, matrix multiplication or any point we shift the vector corresponding to this, and vector is looking like that physical object. It will have a starting point, it will have a end point, it have a length or magnitude, and it has a direction. So, this end point moves. So, if I make a triangle here, so this triangle is made of 3 vectors, and when we transform this 3 vector will transformed. This point representing that vertex, that will remain there, that will be different points and different vertex. So, these are something, but I will not delve much more about that. So, now
So is this going to be equivalent to, when you are saying transforming a point, is this equivalent to aliasing a point, saying that now this point has a new identity? That old point was there, and now it's the if you look at position vector as an identity of a particular point, then that identity has changed.
Yes.
The address has changed.
to some extent you can say that.
Yeah, the address has changed. That,
Yes.
that earlier I used to stay at point A. Now I have moved. Point remains there. I have moved to
Yes.
point A prime.
Yeah, I Chanchal Das can go there,
Right.
but
The point
remains
there.
there.
The objects move,
Yes,
and the vectors that
Representative-
specifying that a particular object moves.
yes,
The point remains.
Yes.
So that means you are saying essentially a static frame of reference.
correct.
You are saying that this frame of reference
Frame is stationary.
static, and now we
Objects are moving. So, all these movements of throughout the globe, whatever the movements are there, all movements can